So at Marvel Labs, we turn biomass into beautiful products while sequestering CO2. Today, we're a B2B white labeling business. Perhaps in the future, we'll be our own brand, but that can involve a lot of heavy lifting. So today, it's B2B. Manufacturing is typically held back by labor. The best way to fix that problem is to reshore locally with automation. This is sort of true regardless of the country. Certainly for the US where I'm from, that's a big problem. But local countries as well have the same issue. We saw a lot of issues with COVID and supply chain disruptions. And so one of the ways to potentially fix this is by focusing on manufacturing locally at the point of consumption. So we've solved this dilemma using 3D printers, and we believe that we're going to be growing exponentially as a result of this. So how do we do this? We take 3D printing commercial grade machines. These machines are typically pretty large. The build area, for example, can be 1 meter by 1 meter by 0.5 meter or more. And we input that biomass. The biomass is in a powdered form. It's the binder jetting process. So it's basically a powder glue, powder glue, powder glue, powder glue. That biomass can be sargassum seaweed. It could be coffee grounds. It could be the coffee cherry. It could be tea leaves. It could be sawdust. We've printed with about 6 different biomass so far. Once it comes out of the machine, the products look a little bit raw, I guess I would say. Like, for example, I can show you, we did a controller here for Sony, but then it gets an additional coating for strength. The step 2 is a little bit optional. It depends if we want stronger parts or if we want the parts to say be a rubber, similar to like a TPU or whatever that is. And then certainly finally on the step 3, we powder coat it or electroplate it and make it look like an everyday product. And then once that's completed, if there's any electronics in it, for example, then those will get added as well. And I mentioned we're B2B at the moment. So as of right now, we are doing all of the assembly as well, putting our business's labels on it and shipping the product. To give you an example of how the process works, you can see here, this is sargassum seaweed ground into a powder. We're taking and spreading a layer of that seaweed. This is a large job box that's slowed down. And then we take our binder and actually make the part itself. So you can see here in kind of the top left, we're printing the parts, and that binder is an all-natural binder that we developed. We have several developed, but that's actually a sugar-based binder. We have a chitosan-based binder, and we have a bacteria binder as well in development. Perfect. This is the sargassum, for example. I think everybody's very, very familiar with it. It always washes up on the beaches. It's one of our favorite materials at the moment to work with. So what do some of the products actually look like? Well, this is a great example of making a sink, for example, from the sargassum, and you can see in the top right, that's the product effectively being manufactured. In the top left, that's the product when it kind of comes out of the machine, and then in the bottom right, when it gets powder coated, it looks like that. We've also made light fixtures, for example. These are made out of sawdust, so a different biomass material. The guitar as well. We've done some glasses for an event that's actually on our LinkedIn page. We just posted that, I think, last night. And so getting into the input costs. So how can we start to compete locally? And again, locally is regardless of the country, but how can you take the input materials, keep them low enough to make products? And so for us, especially if you look at the binder jetting process, it's typically done through metals or plastics, which are expensive powders. If we take coffee, for example, and this is used coffee. So somebody has already made their cup of coffee. They've enjoyed the coffee grounds are done. We take that coffee grounds and turn those into products. And the products, of course, as you've seen, are durable goods type of products. So sinks, faucets, could even be toilets. any sort of product that's largely mechanical at the moment, but then certainly has some electronics added to it. So looking at costs, we did this comparison with Amazon. We looked at light fixtures, eyeglass frames, and faucets. We're typically quite good on the lead time, which is what sort of most 3D printing in general is. But I think where we start to get very interesting is our cost comparison.